In my previous video, I showed you how you can build BGP-based underlays using the open source network operating system, SONiC. In this video, we are going to build on that foundation, and I will show you how you can achieve multi-tenancy by configuring VXLAN EVPN on Enterprise SONiC. If you have not watched the previous video, I would strongly recommend that you start there. Here is a link for it. But if you have watched the previous video, let's start this session. Configuring VXLAN EVPN on SONiC, software for open networking in the cloud. Before I jump onto the SONiC boxes and start configuration, I would like to walk you through some of the important CLI commands that we need to enable VXLAN EVPN on Enterprise SONiC. So remember, we are using industry standard CLI of SONiC in our sessions, which is also called CLISH CLI. So there are two important components that we need to configure, spine and leaf. Let's start by configuring spine. And here is all the configuration that you need to configure spine. It could not be simpler. All you need is one CLI to enable BGP EVPN address family. So remember, in this configuration, we are building on top of BGP Underlay. So BGP Underlay is already configured. BGP neighborship is already formed in address family IPv4. Now what we are doing, we are enabling VXLAN EVPN. On the spine, all you need to do is enable this EVPN address family. And you will have to do it multiple times for each neighbor. In case of leaf, configuration is a little bit more involved. So you start by configuring this VXLAN interface. So remember, this is the interface which will be used for all the VXLAN tunnels. VXLAN tunnels will be initiated and terminated on the VXLAN interfaces on your different leaves. Next step is to enable EVPN address family, similar command. One difference here is that you have this additional command on leaf. You did not need this command on spine. Advertise all VNI. So remember, VNI is the network identifier in VXLAN. Sometimes we say VNI is analogous to a VLAN. Although VLANs are quite limited in number, you can only have up to 4,000 VLANs, whereas VNI is very scalable. You have 24 bits of VNI in the VXLAN header, which means that the upper limit for number of VNI is 16 million. So you have plenty of VNIs to play with. Okay, so you've enabled BGP EVPN on your leaf. Next step is to create your tenants. So remember, tenant is a logical construct in VXLAN EVPN architecture. We create tenant by configuring VRFs. The reason we need multi-tenancy is that multi-tenancy helps us achieve network segmentation, which may be required to satisfy certain regulatory compliance, or it may be needed to meet certain functional requirements of your network. So the number of VRFs you will create will depend on the number of tenants you need. Then for each VRF, you will need to enable your BGP EVPN address family. And you will also issue this command, advertise IPv4 unicast. This is the command which is instructing EVPN to advertise type 5 routes. So in SONiC, SONiC supports type 2, type 3, and type 5 of EVPN routes. With this command, if you don't issue this command, SONiC will not be advertising type 5 routes. So it is required. Next step is to create IRB VLAN and VNI. What is that? So remember, in VXLAN EVPN, there are two modes of VXLAN routing, symmetric mode and asymmetric mode. SONiC support both the modes. In this session, we are going to focus on symmetric mode. I will create another session where I'll talk about the pros and cons of symmetric versus asymmetric. But in most cases, symmetric mode will meet your needs. In symmetric mode of VXLAN routing, you will need to create one VNI specifically for all the layer 3 communication within a VRF, right? You will see that when I say layer 3 communication, I mean, for example, communication between two different subnets. So between VLAN 10 and VLAN, say 20. And I will show you when we go into the lab, you will see that when we are doing communication between, say, VLAN 10 and VLAN 20, I will do a packet capture inside the fabric, and you will see the VNI being used will be the layer 3 VNI, this IRB VNI. But when we are doing communication within the same VLAN, when it is bridging, the VNI used will not be this layer 3 VNI. It will be the VLAN VNI. So I'm going to do a packet capture and I'm going to show you the difference. So hopefully you'll be able to better understand this. Okay, so you create this VNI and a corresponding VLAN. In all our configuration, you will see there will be a one-to-one mapping between a VLAN and a VNI. So this IRB VLAN and VNI, you only create once for a whole VRF. You do this mapping between VNI to VLAN, and you will also map this VNI to your VRF. So with this command, the last command, you are actually telling your switch that this particular VNI is my IRB VNI. This is the VNI that switch need to use for all layer 3 communication in this VRF. That's my step number 3. Let's move to step number 4. In this step, we are creating the server VLANs. So these are the VLANs where you will actually have your end host, your virtual machines, your servers, bare metal or logical, whatever. You will do this step multiple times depending upon how many VLANs you need. So you create the VLAN and you do this mapping between VLAN to VNI. So once again, if I show, for example, VLAN 10 outside of the fabric, you have this identity of a segment as VLAN. When the traffic goes into the fabric, there is no VLAN information in any of the headers. Now the identity of a segment is VNI. So you will have this VLAN to VNI mapping for a successful communication. And the final step, 5th step, is to configure the Anycast address, this Anycast gateway. So remember these leaf switches in your VXLAN fabric, they are providing you routing as well as bridging service, right? So these switches are providing routing service, which means that your SVIs that you configure on the leaf, these act as the default gateway of your servers. And before we want to allow vMotion, because we want to allow our virtual machines to move anywhere within the VXLAN fabric, the IP address, the SVI of the VLAN on each switch is similar. And that is why when the host will move, a virtual machine will move from one switch to another switch, it does not need to change its default gateway. It will get all the services on the first hop leaf. Because it's the same IP we are configuring everywhere, we call it Anycast IP. So this is the final step. And once again, you will do it for each VLAN. All right, so we are entering the interesting part where we will be doing live configuration on our switches. So as you can see, I'm using GNS3 and I am using Enterprise SONiC version 3.1.1 in my lab. In this 3-router topology, I have already configured BGP Underlay, which was part of my last video. So let me quickly show you my configuration, which is already done. Show running BGP on Spine. So you can see Spine is running BGP 65,000, BGP in AS 65,000, and at the moment it's only address family IPv4 which is enabled, no EVPN. Show BGP IPv4 unicast summary. So you can see that spine 1 has two established neighbors with leaf 1.1.1.0 and with leaf 2. But if I look in the EVPN address family, so BGP L2VP, there is no neighbor relationship. Okay, so let's do this configuration. It is fairly simple on spine. All I have to do is enable EVPN address family. Configuration mode, router BGP 65,000. Okay. And now I'll do it for each neighbor. 1.1.1.0 address family L2VPN and activate it. I'll do the same for leaf 2. Activate. And that's it. That's my EVPN configuration done on spine. Okay, let's do the same on leaf 1. So remember, on the leaf side, the configuration is more involved, as I said earlier. So we will be doing VXLAN configuration as well as our tenant configuration and BGP configuration. So we start by configuring a loopback interface, which will bear the IP address for our VXLAN interface. So 100.1.1.1, as you can see, will be the source address of our VXLAN interface. All the communication within the fabric between these leaves, all the data that will flow will contain this IP in the outer IP header. I'll show you that. And then we will enable L2VPN address family on leaf as well. Okay, so let's jump to leaf 1. So on leaf 1, I start by verifying underlay configurations. So running BGP. It's got one neighbor, which is spine, and only address family IPv4 at the moment. So BGP IPv4 unicast summary. So neighborship is established. All right. Just to save time, I'm going to copy paste this configuration here. Okay. So if my configuration is correct, I should see now a neighbor relationship in the L2VPN family as well. And I have a neighbor relationship in the L2VPN as well. Okay, let's do the same on leaf 2. But in case of leaf 2, my VTAP address will be 100.2.2.2. So I've chosen these IP addresses. So I know this is leaf 1 and leaf 2. So leaf 2 is 100.2.2.2. And then I will enable BGP EVPN. So I'll copy this configuration and I'll go to leaf 2. Okay, so on leaf 2, first of all, I'll verify underlay. So BGP IPv4 unicast summary. And my relationship with spine is working. Okay. All right. So let's look at the EVPN configuration now. So let's see if the neighborship is up in the EVPN families. So BGP summary, and my pairing is up. You will notice that I'm not receiving any routes as yet, and that's because I am not advertising any EVPN routes so far. That will come in the next section. I have also configured my VXLAN interface. So there is a command to verify my VXLAN configuration, VXLAN interface configuration as well. The command is show VXLAN interface. So I can verify my configuration. It looks good to me. If I do show VXLAN tunnel, so we have configured VXLAN on both sides, leaf 1 and leaf 2. Is the tunnel up? No. Why? Remember, VXLAN tunnel will be dynamically formed once we learn some EVPN routes. You'll see in the next step. All right, so this is my basic VXLAN EVPN configuration done. Let's jump to the tenant configuration now. Okay, so I'm on leaf 1 now. So let's quickly have a look at our tenant configuration. So we will create a VRF. This command basically will define the MAC address that will be used for all the static Anycast gateways that you configure, all the Anycast IP addresses that you will configure on your SVIs. This MAC address will be used for those SVIs. It could be any MAC address, but we want to manually define a MAC address so it is consistent. Then we enable our BGP. So remember this command. After this command, you will start seeing some of the type 5 routes advertised in EVPN. I talked about IRB, VLAN, and VNI. So this is what we are defining here. I'm using VLAN 2000. It could be any VLAN number. What I tend to do is I tend to use a VLAN for my IRB VLAN, which is quite different from all my server VLANs. So I can easily identify it. Okay. You will also notice that I've enabled IPv6 here. It doesn't have to be IPv6. This interface, your IRB VLAN interface, it should have an IP address. Could be an IPv4 or IPv6. This is required for DHCP relay functionality. So I just find it easier to enable IPv6. It could be any IP address although. Okay. This is where we are defining our VNI. So this is VNI 200.000. This is the VNI which will be used for all layer 3 communication in VRF1. When I'm going to do packet capture for my routed communication, you will see this VNI will appear there. This is my server VLAN, interface VLAN 10. I'm just calling it green servers and I'm assigning this IP. So this interface here on leaf 1, Ethernet 0, here I will enable this VLAN 10. And then I'm doing the mapping of this VLAN to a VNI. What I tend to use, I mean, you can use any VNI number. What I would recommend is that you use a VNI which is somehow similar to your VLAN, so that when you look at your VNI, you can easily map it to your VLAN. So what I tend to use is I do 1,000 and the VLAN number. So for example, when I will configure VLAN 11, I will choose a VNI of 1,000.11. The next step is this interface Ethernet 0 configuration, this interface configuration, and I am allowing VLAN 10 on this interface. Okay, so that's my configuration for leaf 1. Let's copy and paste on leaf 1. We'll have to go back to SONiC CLI or Clash mode, configuration, and I'll just paste this configuration here. Okay. Looks like it worked. Quick verification. So I can do a show VXLAN VLAN VNI map. So this command shows me my VLAN to VNI mapping. Looks good. Show VXLAN VRF VNI map. This is showing what layer 3 VNI will be used in this VRF. This is the layer 3 VNI. Good. So that's my configuration done on leaf 1. Let's quickly do the leaf 2 configuration. So I've not created any configuration for leaf 2 yet. I'll do it right away. So I wanted to show you how similar these configurations are. becomes so easy to automate it as well. Okay. So just copy paste this leaf one. So I'll keep the VRF obviously number. I'll keep the Anycast MAC address, very important. AS number here is 102, as you can see, and the router ID is 0.3. I'll keep the same VLAN, IRB VLAN, same VNI, of course. I will keep VLAN interface VLAN 10 here as well. In addition to that, I will create VLAN 11 as well, an extra VLAN. So copy paste it here. So VLAN 11, let me call it red server VLAN. Subnet here, I want to use 11.1.1.250, or as you can see, this endpoint I've already configured in subnet 11.1.1. And VTEP, excuse me, mapping. So VNI 1000011 to VLAN 11. Ethernet 0, this interface configuration. So I'm calling it endpoint 2. And I'm adding, let me add 10 and 11. So I'm adding both VLANs on this. In the first go, I will just enable, I'll just be doing communication between 10.1 and 11.1. Later on, I'll do communication, I'll do bridging. So I'll do communication between 10.1.1 and 10.1.1.2 on the other side. Okay, so let's copy paste this configuration on leaf 2. SONiC CLI, configuration mode. Okay, so remember my verification commands: show VXLAN, VLAN VNI map. This looks good. And show VXLAN, VRF VNI. Yeah. This looks good as well. So this completes my configuration on my leaf as well. Is the tunnel now up? Show VXLAN tunnel. No. Why? Because these are silent hosts. These are basically SONiC switches, my endpoints. They're not generating any traffic. That is why there is no endpoint discovered or learned on the leaf. And that is why there is no tunnel formed. So let's generate some traffic from our endpoints, and then we will see the tunnel is formed, and we will also see how the control plane looks. Okay, so we are on endpoint 1, and if I do show IP interfaces, you can see IP configured here is 10.1.1.1 as shown here. And I will ping my default gateway. 10.1.1.254. I can ping it, and if I do show IP ARP, you can see the Anycast MAC address that we configured appears here as the MAC of this Anycast IP address. Okay, let's do the same from endpoint 2. Ping 11.1.1.254. If I do show IP interfaces, you can see IP here is 11.2 as configured here. And if I do show IP ARP, same MAC address. All right, now let's go to our leaf and see how these endpoints are learned and what EVPN routes now we have learned, and is the VXLAN tunnel now up or not. So let's go to leaf 1. SONiC CLI. Show BGP. Let's have a look at show BGP L2 VPN EVPN summary. And you can see we are learning some routes now in EVPN family. Show BGP L2 VPN EVPN route. So this command will show me the whole routing table of EVPN, all the route types. So I'm learning some type 5 routes, 10.1.1.0 prefixes, and I'm also learning type 2 routes. The type 2 routes are the host routes, MAC and IP routes. As you can see, I'm learning 10.1.1.1, which is coming from this very router, 192.168.1.1, leaf 1, and I am also learning 11.1.1.2, and it is coming from 192.168.1.3. How do I get there? By going to 100.2.2.2, this VTAP IP. Okay, so the control plane looks good. Let's do the, the VXLAN tunnel as well. So show VXLAN tunnel, and it is up now. Let's go to leaf 2 and verify. So on leaf 2, show VXLAN tunnel. It is up, and you can see the source will be 100.2.2.2. Destination is the VTAP of leaf 1. Okay. Show show L2 VPN, show BGP L2 VPN EVPN routes. We can see all the routes. If I want to specifically look at a specific route type, only type 5 or type 2, I can do that as well. So let me show you that actually. Route type, and if I do a question mark, you can see I can specify if I want to, for example, just look at type 5 routes, I'll use keyword prefix, or just type 2 routes, MAC IP. This is probably not very significant when you look at it in the context of this lab. But when you're looking at a large live network with hundreds of leaf and thousands of these endpoints, these type of options become very handy. So if I just want to look at type 2 routes, I use the keyword MAC IP. And here you can see on leaf 2, I know how to get to 10.1.1.1 by going to 100.1.1.1 VTAP IP, and I'm learning it from leaf 1. All right, so my control plane all looks good. Let's do the final bit and do some pings between endpoint 1 and 2. From endpoint 1, I do ping 10. Other side is 11.1.1.2. So I'm pinging from 10.1.1 to 11.1.1.2, and I can ping it. If I now do a quick packet capture, and that's where GNS3 really comes very handy, I can just do it with a right click. I'll go here, right click, and start capture. It will open up a Wireshark window. You need to have Wireshark on your computers to do that. And there you go. I'll just stop this capture and look at one packet. 10.1.1 going to 11.1.1.2. So this is the source and destination. But if you look at the outer IP header, you see it shows a different source and IP. So the outer IP header will always contain source and destination of the tunnels, 100.1 to 100.2. UDP header shows port number 4789. Now this is the well-known port number for VXLAN. That is what is used in SONiC as well. And if you look at inside the VXLAN header, the important field of interest is VNI. Which VNI we can see here? This is the VNI of our VRF that we configured here. So remember, 200,000, right? So this is the VNI being used here, as I mentioned. But if I change it now, if I do communication within the same VLAN from VLAN 10 to VLAN 10, will I still see the same VNI? Answer is no. In that case, I should see the VNI of the VLAN. Let's quickly test that. Okay, so what I've done is on the endpoint 2, I changed the IP to 10.1.1.2. On the leaf, we already have configured VLAN 10, and the SVI for VLAN 10 is already configured on leaf 2. So the leaf 2 side was already prepared for this scenario. So this is the IP I've assigned. If I ping my default gateway 10.1.1.254, I can ping that. And if I do show IP ARP, I can see my ARP. You can see this is the same physical IP that we, same MAC address, Anycast MAC address that we configured. Okay. And if I ping 10.1.1.1, so I'm pinging from leaf to, sorry, from endpoint 2 to endpoint 1. And as you would expect, now we can ping that. Now, if I do a packet capture here, the last thing that we're going to see, let's see what is the VNI being used. So this is the packet. You can see it's source and destination. In the outer header are VTEP. You go to the VNI, you can see it is using the VNI of the VLAN 1000010 as we configured here. 1000010. Okay, so this completes our configuration and verification of VXLAN EVPN on SONiC. If you have any question about the content we covered in this video, please ask in the comment section. You can download full configuration of all the switches used in this session via a link in the description of this video. Thanks for watching, and I look forward to seeing you in the next session.